Hello, today I'm going to tell you about the Chernobyl disaster of 1986. Once upon a time, there was a city called Chernobyl, and in this city there was a power plant. The power plant had a reactor that exploded and caused radiation levels 200 times greater than the atomic bombs dropped in Hiroshima and Nagasaki combined. The aftermath of this event was tragic to all organisms. But this wasn't the only time something extreme like this occurred. More recently, in 2011, there was a nuclear explosion in Fukushima. Because the same species of birds inhabited both sites, this provided the perfect opportunity for researchers to observe the long-term effects of radiation on the species under the same conditions. The researchers used their studies on the birds in Fukushima in order to observe how the birds in Chernobyl have evolved since the original event. It turns out, birds in Chernobyl have better survival rates than their counterparts in Fukushima. The scientists hypothesized that the birds from Chernobyl have had time to evolve resistance. Thus, they are better adapted to a radioactive environment. This means that there is something about the underlying genotype of the birds in Chernobyl and Fukushima that has become, well, different. This change in DNA can be explained through the idea of evolution. Evolution is driven by the process of natural selection, which increases the frequencies of certain more fit alleles in a population over time. In this way, if some random mutation ends up benefiting the individual, it is more likely to produce viable offspring who will also have that trait. This individual is considered to be more fit than others in its population. Subsequently, that good trait will increase in the population and occur in higher frequencies in the gene pool of the next generation. This is how species evolve. They become better and better adapted to their environment from generation to generation, as the beneficial allele becomes more prevalent. This is exactly what the researchers believe took place in Chernobyl. So what trait could the birds have possibly evolved to combat the deadly radiation? Why do birds with great-great-grandparents that were exposed to radiation survive better than first-generation birds? First, we need to look at exactly what the consequences of nuclear radiation are. Birds are harmed and often killed by ionizing radiation, which causes damage in cells. But it turns out that living things are not completely hopeless when their environment suddenly changes on them. Birds use antioxidants, particularly glutathione, to combat cell and genetic damage. So it looks like glutathione level is an important factor in deciding which organisms survive better than others. In fact, the researchers found that birds in low radiation zones had a lower concentration of glutathione than those in higher radiation levels. More importantly, birds with lower amounts of genetic damage also had high glutathione levels. Therefore, birds with greater amounts of glutathione survive better in radioactive environments. So, how exactly do glutathione levels differ? There must be some underlying genetic difference that allows the birds in Chernobyl to survive in radiation levels where the birds in Fukushima cannot. The researchers found that the type of melanin may directly influence how glutathione is used in the body. The birds studied in these sites had two variations of the pigment, pheomelanin and eumelanin. Pheomelanin produces a lighter color, which is better for concealment, but at the cost of using very high levels of glutathione in its production, while eumelanin, which causes a darker color, does not. With the atmosphere in a normal condition, having pheomelanin is no big deal, because the glutathione is not needed to fix genetic damage. However, when disaster strikes and glutathione is suddenly required for the organism's survival, having pheomelanin may not be so advantageous. This means that more birds with pheomelanin will die than birds with eumelanin as a result of the radiation, thus immediately changing the allele frequency in favor of eumelanin. As a result, this shifted parent population will produce more offspring with the eumelanin trait. This process will be repeated every generation, making the future generations better adapted and fit for their environment. If radiation levels persist, then individuals with the eumelanin trait will continue to be more fit. They will survive better in the radiation background. This explains why the researchers found that birds with higher radiation zones were eumelanin-based and had a greater amount of glutathione. As for the birds in Fukushima, their lower levels of glutathione, even when exposed to the same amounts of radiation, can be explained by this very same process. Since this accident only occurred recently, in 2011, the population has not yet had the opportunity to reproduce for many generations and change the allele frequency significantly. Thus, birds in Fukushima are simply not yet as well adapted to the radiation as the birds in Chernobyl. However, if evolution really is occurring, then glutathione levels will continue to rise in the population following the historical trend. This is significant because it is a real observed instance in which the effects of evolution were clearly visible.